about food and climate change. So please give a very warm welcome to Sarah Bridle.
That's great, thank you. Thank you. Thank you very much indeed. Well, thank you for coming and coming to hear about this really interesting topic. So I'm going to be talking about a bit about climate change. I gave this similar talk last year and the year before at Blue Dot. And while I was preparing my slides for this talk, I realized that I needed to cut lots of my slides on climate change because there's been so much talk about it in the last year. But just a quick question. Oh, that's the wrong button. Hold on. Let's try that again. There we go, the right button. Okay, so big question. Hands up if you think this graph of temperature against number of years, is this graph going up? Hands up if you think it's going up. Okay, thank you. Hands up if you think it's not going up. Okay, I just root out the controversies early on. Okay, that's great. So this is the graph that my colleague Brian Cox threw at the climate skeptic in Australia, and the discussion there was about whether this graph is going up. The scientific consensus from the International Committee on Climate Change, warming of the climate system is unequivocal. There's another version of this which I think is really beautiful. Why is this not working? Okay, here we go. This is a beautiful project called Climate Stripes. You can download this for your own city or country. And this is just showing the average temperature for each year since 1850. And it's showing it in different colors. So the question here would be, do you think that one side of the graph is more red than the other side of the graph? I can see some laughing there, okay. But no matter what you think about what's happened in the past, okay, this is not working as well as I'd expected. I shall just press the button. Okay, so no matter what's happened in the past, really we're all concerned about what's going to happen in the future. And so this kind of graph of the amount of carbon dioxide in the atmosphere going up here, now above 400 parts per million, is really what's important if you believe the science about global warming. Saying that light's going to come in from out the sun, it's going to warm up the Earth, and then that infrared radiation, that heat, is trapped by these greenhouse gases. So if we look into the future, well, we don't know, nobody knows what's going to happen in the future, but these are some different scenarios that have been considered by the international scientific community, depending on how much greenhouse gas emissions going up there as a function of time, or maybe we will reduce greenhouse gas emissions and eventually be sucking carbon dioxide out of the atmosphere by the end of the century. This mouse button is going a bit crazy. Let's put this down. Okay, so no matter which of those we're on, it turns out that the more greenhouse gas emissions we have on the bottom of this graph, then the higher the temperature at the end of the century, very roughly. So for the rest of this talk, we're going to be focusing on the amount of greenhouse gas emissions. I'm going to try an audience poll. So I'm going to try an audience poll of how much more food do you think we're going to need by 2050? So I've got a few options for you here. So I'm going to ask for hands up if you think we're going to need 10% more food by 2050. Thank you. Hands up for 20% more food by 2050. Okay, hands up for 30% more food. Hands up for 50% more food. Hands up for 70% more food. Great. So different estimates say different things. I think this room has said between 30 and 50%. Most estimates say 50 or more % more food. So this is the World Resources Institute version of that calculation. Different versions depending on the projection for the population of the world, which obviously is a very important factor. And then the other important factor is how much food each person wants. And so you can see here a graph showing the amount of calories people want versus the amount of money that they have, roughly. And so what you can see here is that the more money people have, the more calories people want. There's a really interesting thing you can see already on this. Anybody been on a diet ever? Okay, no one's owning it to it this evening, but if you've ever been on a diet, then you will know roughly the amount of calories that people need is about 2,000 to 2,500 calories. So what's happening? Why are there so many people wanting more than 3,000 calories? Two main reasons: obesity and food waste. So there is lots of people wanting more food than they really need, which is one big issue. So that partly drives that number that we just saw. So are we going to try and meet the global demand for food, or do we need to manage our demand for food? Okay, if we look into the future, then we've got an impact of climate change on food production. So if we look ahead, then more carbon dioxide in the atmosphere can have some benefits. So, for example, global warming can cause some countries which had maybe the cooler climates can actually produce more food. So some people benefit from global warming, but at the same time, some plants actually grow faster when there is more carbon dioxide. But the disadvantages are that often the nutrition is lower in the plants which grow faster. And that's a serious issue that's being considered a lot in the scientific community at the moment. But another problem, of course, there are many countries, especially near the equator, which produce a lot less food. So on average, globally, we're going to see a lot of yields going down, producing the lower of these two bits of millet here rather than the upper, for example, depending on the weather. And then depending on how you do the calculation, a reduction in yield and a corresponding increase in the price of food. Now, factually, when you have an increase in the price of food, then that can cause other problems beyond the food system. This is a very now famous graph showing the price of food, and in red, food-related civil unrest, which, we don't know what's going to happen in the future. Sometimes it's a perceived lack of food rather than an actual lack of food, but these are issues we need to consider. Maybe other new foods that we hadn't previously eaten so much of will become more popular. Anybody like black eye beans here? Hands up. There's lots of people here. Wow, fantastic. So this is a type of food that has been investigated as a potential food that could grow in space because it's so hardy. But I thought I would Google some delicious recipes using black eye beans, so you can check those out later if you didn't put your hand up already. So there's lots of possible outcomes. Most of this talk, I'm going to be talking about a different topic: the impact of food production on climate change. So I'm going to do another poll now. What fraction do you think, what fraction of greenhouse gas emissions globally come from food production, including agriculture, land clearance for agriculture, food processing, transportation, and so on? So I'm going to do a poll. So who thinks 5% of greenhouse gas emissions come from food? Okay, who thinks 10%? Hands up. Who thinks 20%? Thank you. Who thinks 30%? Who thinks 50%? And who thinks that I'm trying to trick you by giving you another question which was right off the chart? So yeah, depending on how you do the exact numbers, it's currently between about 20 and 30% of greenhouse gas emissions coming from food. But if we look into the future, then as there are more people demanding more food, this number is expected to go up. If people are demanding more carbon intensive or more greenhouse gas emitting foods, this number will also go up. But also, as we have more renewable energy, in the rest of the greenhouse gas emissions might go down, hopefully, and food will become an increasingly large fraction of the greenhouse gas emissions. So I think this is going to be where we're talking about in 10, 20, 30 years' time about greenhouse gas emissions. It's going to be about food. I won't go through this graph, but the slides are on our webpage if you're interested to study it in more detail. This shows you different types of activity and how they contribute to greenhouse gas emissions. There's a beautiful chart showing food here, producing more greenhouse gas emissions, for example, than heating for personal comfort, so warmth in houses and buildings, more than mobility and freight there. So this is a significant fraction of greenhouse gas emissions. For those of you interested in more detail, you can read this in your spare time, but you can see a lot of detail on there, which I think is just so fascinating. And you can see rice paddies on there, cows. You can see clearing of land for agriculture. It's all on there. So I got curious about this, and I started to do some calculations. Every year or two, there is a survey of people in the UK asking them what they eat. And so this is done for about 4 days. Imagine writing down everything you eat for 4 days. Guess what? On day 4, people eat less than on day 1. It's quite boring. But this does happen, and the data is analysed, and we analysed some of this data, matching it up with the greenhouse gas emissions for different types of food. And so what you can see on this graph here is the different amounts of energy from different types of food. So we get the largest part of our energy from bread, pasta, cereals. No great surprise there. We can actually reverse this graph and change the order so that we're looking at the greenhouse gas emissions in order. So what we can see here is the largest category on this graph here is greenhouse gas emissions from beef and lamb, followed by milk and cream, and then cheese and butter. So this is already making up more than 1/3 of the greenhouse gas emissions, and we're going to talk a bit more detail about that now. I want to know why do these particular foods cause greenhouse gas emissions? So I do eat meat. I do think this looks delicious. I'm quite hungry right now. Not everybody in this room will agree with me, but let's talk about cows. So this cow, so innocent, eating some grass there. It looks delightful countryside of the UK. What could possibly be wrong? We've been running a stand in the emission control exhibition space the last 3 days. I've talked to lots of people. Lots of people are quite familiar with this, so I think that's really a big change from last year. This is a cow's stomach. The cow's stomach has multiple compartments, and the rumen compartment of the stomach contains microbes that turn about 5% of the calories eaten by a cow into methane, which is burped. I'd just like to correct a few people on this, burped out of their mouths. I don't know what cows burping look like, but I'm guessing this might be one. So cows eat about 40,000 calories a day, and so about 5% of that is causing methane to go into the atmosphere. Methane is about 30 times more powerful as a greenhouse gas than carbon dioxide. So this is a serious issue. But how can we calculate the greenhouse gas emissions from a piece of beef? We need to know how long the cow is alive for, burping methane into the atmosphere. So in order to produce some beef, we need to grow a calf from birth to when it's fully grown, ideally. And also, we have to have a mother cow, alive for 1 extra year to produce 1 extra calf. So if we look at this system in more detail, we can calculate the greenhouse gas emissions from a piece of beef. The majority of that comes from the methane. We've been running a stand just in there. As I said, this is a photograph of us on the stand earlier today. Can you see these balloons in the background? There's some white balloons at the back there. It took a while to blow them up. Some of them popped overnight, but there's about 40 or 50 balloons there. And I've been asking people, how much steak do you think you need to eat to cause the equivalent of that amount of carbon dioxide to go up into the atmosphere? I've not prepared a hands-up quiz for this, but I've had a lot of different answers. the size of a cow. I've had that answer. I've also had 1 gram, so we've had the full range. One person was spot on, about 50 grams. That's about half the size of a piece of beef, half the size of a beef burger. A size piece of steak. You're responsible for putting that much equivalent amount of carbon dioxide up into the atmosphere. So we are not lobbying for any particular outcome from this. We're scientists. We want people to know the facts and to use those facts to try to understand what is best to do with this, but this is one of the facts. You might be interested to know that you could have 5 times as much chicken, so about 270 grams of chicken. That's a really big chicken breast, or maybe 2 smaller chicken breasts, for the same amount of greenhouse gas emissions, or 5 times as much again of beans for the same amount of greenhouse gas emissions. Now, I am getting a few questions about the beans. I think I should address this now. There are concerns from a number of people who have visited our stand about personal emissions, I'm going to call them. So I need to tell you that methane is not necessarily produced by people in response to beans. It's actually genetic, whether or not you happen to produce methane. It's not linked to the beans. However, depending on the amino acid balance of the particular pulses or beans or lentils you're eating, there can be more sulfurous emissions. I'm just saying that, and that's all I'm going to say on the topic. So, for example, this is a very interesting study of New Zealand lamb, looking at the greenhouse gas emissions from lamb, which have the same type of stomach as beef, which I'm extremely disappointed about, because I absolutely love lamb. But in terms of greenhouse gas emissions, then the majority of the greenhouse gas emissions are happening on the farm. It's not the transportation by ship. And so, you know, the details about the transport and the ocean shipping is not such a big deal, because of the methane being relatively large and the farm emissions being a relatively large part of the greenhouse gas emissions. So that's one of the questions I often get asked about local versus the type of food that you choose. I'm going to go back to this diagram now and talk about the next thing on the list, which is milk and cream and cheese and butter. Again, I get asked a lot about packaging, different types of milk bottle, plastic versus glass. And again, the same story. It's about what is in that packaging. For the higher emissions foods, it's much more about what you're buying than about the packaging for those higher emissions foods. We're going to talk about cheese as well. Typically, a cow might live for, say, 4 years, producing milk for the last 2 of those years. About half the beef in the UK comes from dairy herds. That's something that also shares some of the greenhouse gas emissions from the milk, which helps to reduce the emissions from the beef and the milk. If we can share those emissions out between different things. We're back to the cows. It's the same animal producing the milk and the beef. Hands up if you've ever made cheese. Anyone made cheese here? I can see a few hands up there. Great. So you put this rennet into the milk, and you produce this gloopy stuff. This lovely cheese. Now I've put this picture in here to illustrate the amount of whey that you produce when you make cheese. So it turns out that to make 1 kilo of cheese, you need about 10 kilos of milk. So so that increases the greenhouse gas emissions, per kilo for cheese compared to milk. It's about 10 times the greenhouse gas emissions for 100 grams of cheese than it is for 100 grams of milk. So that's basically why. Okay, so I'm going to move on now to bread, because that's one of the things that causes the most, it gives us the most energy, but it's a relatively low emissions food. So how do we make bread? This is just a gratuitous picture of Marmite on toast, just to make me feel really even more hungry. So I wish I hadn't put that in now. But when we grow, how do we make bread? So we have to grow some wheat. We have to take the grains out of the wheat. And one of the things that we do when we grow wheat is we have to give it fertilizer. So the main way that we get fertilizer for wheat is to use ammonium nitrate. So this is nitrogen from the air combined under pressure in order to produce this synthetic fertilizer. It looks a bit like sugar, and about 1 teaspoon of ammonium nitrate is used to grow about enough wheat for 2 slices of bread. But don't put this in your tea, because it's also the main ingredient in lots of explosives. So that's particularly interesting because whatever sort of fertilizer you use, whether it's manure or whether it's synthetic fertilizer, when you put fertilizer on the ground, then microbes, it's microbes again, microbes in the soil this time, instead of microbes in the stomach of the cow, these microbes in the soil will turn about 1% of the nitrogen into nitrous oxide. Now, nitrous oxide is also laughing gas, but it's no laughing matter because nitrous oxide is about 300 times more potent as a greenhouse gas than carbon dioxide. So the main way that most plant-based foods, contribute to greenhouse gas emissions is through the nitrous oxide that's put on the fields and also the production, the energy that's used to produce the synthetic fertilizer, about the same quantities of greenhouse gases from both of those sources. So we can do a calculation of how much greenhouse gas emissions come from bread. You might be frightened by this number, but it turns out that when you put it into perspective with all the other numbers, then it's less of an issue. We're going to make a cheese sandwich now. We're going to make a cheese sandwich, and we're going to calculate the greenhouse gas emissions from the different components of the cheese sandwich. So we've got the bread, 2 slices of bread. We've got some butter. We've got that's about a tablespoon of butter, and then we've got about 50 grams of cheese. So this is roughly what happens when you add up the greenhouse gas emissions, typical values for greenhouse gas emissions. So you can see there that the bread, don't stress about the bread, okay? So this is, what else could we do? What could we have instead of a cheese sandwich? We could have a beef sandwich. How about that? So if we had a beef sandwich, then that would cause more greenhouse gas emissions. However, what about a chicken sandwich? So we could reduce the emissions by switching to a lower greenhouse gas emissions food like chicken. Where does the greenhouse gas emissions come from a chicken? Chickens don't burp, as far as I'm aware. I did actually I did type chickens burping into Google just to check. Apparently, you can burp the little chicks to stop them from having bubbles, like you burp a baby. So there is some information on burping chickens, but it's nothing to do with methane. It's all about the food that is fed to the chickens. So we have to grow food to feed animals like chickens, and that is the main source of greenhouse gas emissions for something like a chicken. So there's big differences between different sorts of food. That's the main message I would have for you. What other things we could do? We could just reduce the amount of cheese. So if we halve the amount of cheese, maybe add a bit of pickle to make up for it, then we can already make a big difference to the greenhouse gas emissions from the sandwich. What about instead? There's a lot of different cheese alternatives out there. I'm not going to worry about that too much. I'm going to suggest a bit of peanut butter and jam, unless you're a nut allergy, of course. But peanut butter and jam is, you can compare those numbers. I'm not advocating any particular solution. I'm just a scientist telling you the facts. This is the comparison of the numbers. You could actually reduce your greenhouse gas emissions by nearly a factor of 6 by switching to a different different alternatives. So there's a lot of information there, a lot of things we can do to address, reducing the amount of the highest emissions foods in our diet, which would reduce the total emissions from a sandwich. One thing I think we can probably all agree on is that wasting food is not a great thing to do. I only learned a couple of years ago that it's not just because you've wasted the you've produced that food, and when you produce the food, it causes greenhouse gas emissions, and you've just gone and thrown that away, so what a waste of those greenhouse gas emissions. That's not the main issue with food waste. The main issue with food waste is that when food goes to landfill sites, then it can't compost properly, and it turns into methane. So you've got carbon in the food. It's trying to break down, it's trying to rot. When food is on a compost bin, then it rots into carbon dioxide. It has access to oxygen in the air, and carbon turns into carbon dioxide. If you have food rotting where it does not have access to the air, then it turns into methane, which is carbon and 4 hydrogen atoms. It doesn't have oxygen, it can't produce carbon dioxide. That sounds like it'd be better because, carbon dioxide is a greenhouse gas, right? But actually methane, for each carbon atom, methane is 10 times more powerful as a greenhouse gas than carbon dioxide. So basically what's happened if you grow food and then waste it and put it in landfill is that you've turned carbon dioxide into plants. Good. We've taken carbon dioxide out of the atmosphere. But then, if it turns into methane, then you've just turned that carbon dioxide into something with 10 times the greenhouse gas effect. But if it rots into carbon dioxide, it's just returning that carbon dioxide into the atmosphere. So let's reduce waste. Did you know that 70% of people in the UK think they do not waste food? I'd love to say I didn't waste food, but I think that it's basically the problem is we don't think, what food shall I waste today? It's not on the list, is it? Waste food. I'm trying to find something to eat for my dinner, and there's some moldy bag of salad in the way, and we don't look at it because we don't want to think about it. But actually, there's a lot of talk about supermarkets causing food waste in the supermarkets. But actually, if you look after the farm gate, then about 70% of the food waste in the UK is happening in the home. That varies a lot depending on what country you're in. I won't go into the details. But overall, over 20% of all bread is wasted, for example. And just to talk a bit more about the meat, if we just were to reduce the amount of meat we're eating to follow the government guidelines, then that would help with the greenhouse gas emissions significantly. So the government guidelines currently say a maximum, it's not a requirement, it's a maximum of 70 grams of meat per day. So this is health guidelines for health reasons. There's some pretty cool things you can do. I'm not advocating any particular, I don't get money from these people, I'm just think it's really cool that there's lots of technology that can help reduce greenhouse gas emissions. We can have less greenhouse gas emissions intensive foods, maybe even lab milk. There was a big announcement last week that these guys are now selling ice cream, that they've used, they're making milk proteins in the lab using a kind of effectively kind of yeast. But looking into the future, what's going to happen? In the future, what will we be eating? Hands up if you've ever taken vitamin tablets. Lots of people. What if we really needed to get our nutrition for the minimum greenhouse gas emissions? What would we invent? Maybe we would invent something which was basically a vitamin tablet, And what if it was some sort of grey goo, like in some of the science fiction films, and that was the lowest greenhouse gas emissions food we could think of? I think that probably would be the lowest greenhouse gas emissions way to get our nutrition. How do people feel about that? You may think it's very efficient and easy to drink some grey goo. There are a number of products available which you can drink and get all your nutrition. There's also very cool things you can do with other nutrition sources. Anybody know what's in this picture? Insects, very good. So have you ever eaten a pink marshmallow? Not a lot of people owning up to this. Okay, so if you bought a regular pink marshmallow, that contains something called cochineal, which is these bugs here living on cacti. If you grind these up, it makes a lovely pink colouring, which is natural. So that's great news. It means you've already eaten insects through your marshmallows. There's a number of products available. We've been giving away free insects over there. It's probably the lowest greenhouse gas emissions source of animal protein that you can get. I'm just going to put a shout out to this incredible magazine. If you've got kids or grandchildren or anybody that has access to giving kids a really cool science magazine that they love, that I recommend, Whiz Pop Bang. They're not paying me, but we do get it because it's great. You can buy insects if you want to buy insects. We're giving them away at our stand, which we've just packed up, I'm afraid. But we've given away a huge amount of marshmallows as well. That went down very well, turned out. But you can find out more about all these things on our website. So if you go to GGDOT.org, which you can also get to from our main website on my back here for our stand, and check out what we've got there, then you can find out more about some of the things that we've produced to try to help tell people and communicate these facts with people about foods. So you can play this game, Climate Food Challenge. You can guess which food you think has the lowest greenhouse gas emissions. You can also download these food flashcards with information about greenhouse gas emissions for different types of food. We've converted it into the equivalent for driving a car, the number of minutes driving a car, and how much greenhouse gas emissions would that cause. And what I like about that is that you can sometimes think, well, there's maybe a lot of emissions from something, but then actually we often would drive 15, 30 minutes without necessarily worrying about the greenhouse gas emissions, but that's comparable to eating some of these things. So just to put it a bit into perspective. If you're really keen, you can even click through to find out all the details of all the research papers that we got these numbers from in the academic literature, if you're really keen. So looking ahead, what would we like to see? Sign up to our mailing list, and then you can find out about new things that we produce that might be useful and fun to learn about greenhouse gas emissions. I was on a panel discussion yesterday about labeling of foods, and I'd love to see, the best response I get to showing people these cards is, this is nonsense. There is not one number for a piece of ham, right? There's not one number because it depends on many things. It depends on how long the pig was alive for. It depends on how the manure was managed. It depends on how it was processed. It depends on where it's coming from. So there's a lot of details which are different for different ways of producing food. And ultimately, we need food producers to tell us this detailed information. And I think that would be my dream, would be for people to demand this information to be provided by food producers. I'd love to see some sort of labeling on products so that we don't have to, go to the academic literature to tell you these numbers, but you get the real numbers for the exact way that each food is produced. I'm currently writing a book on food and climate change, which hopefully will come out in the coming year. There's an amazing book you can already read about energy, which some of you may know already, written by this fantastic person, David Mackay. And I'd love to see something akin to the 2050 energy calculator, now called the Mackay calculator after David Mackay, for food. So please sign up to our mailing list, and I'd love to hear your questions on what I've just talked about. Thank you very much. Thank you. Thank you.
Okay, thank you very much, Sarah. Any questions?
Hiya.
Hi.
Thanks for the talk. Just an interesting, well, just a question really. There's a lot of focus on higher welfare animals, that kind of thing. People looking at like rare breeds, older versions of pigs that we used to have in this country, as opposed to the commercial pigs.
Yeah.
A lot of stuff, a lot of food comes from. Actually, are they worse for the environment?
Okay, so are higher welfare animals worse for the environment and older breeds? Okay, so there's a few issues there. So the longer animals are alive for, the more greenhouse gas emissions they produce. So having higher animal welfare and reducing the number of sick animals does help. Okay, so this is a win all round. Older breeds. I don't see why that, I don't know any studies looking at older breeds. I don't see why that would make a difference to most of these things, because in terms of the amount of greenhouse gas emissions, for example, from manure or feed, it all comes down to how much the animals eat and how fast they grow. I would actually bet that it was not helpful, because that's one of the things that we breed for, is growing quickly for a small amount of food. So that's my guess on that, but I don't know about older breeds. Yeah, thank you. It's a good question. Hello.
Hi. Looking at the chart that showed the carbon footprint from the different foods that people ate, probably about 50% of that, if you want to bring it up, about 50% of that top section there was from animal agriculture. Mm-hmm. And also the amount of land that's given over to animal agriculture, would that land be better served by growing plants for human consumption rather than animal consumption, moving towards a plant-based diet?
That's a great question, yeah. So obviously, if we all stopped eating meat, if we just took all of that out of our diet, then we would be hungry. So we'd have to fill it in with, it all depends on what we replace it with. And so, as you say, for plant-based options, we could get nutrition. If we are very careful, we can get all the nutrition we need from those plant-based options. But, where am I going with this? Yeah. So we've got to be careful. If everyone stopped drinking milk, for example, then there would be a nutrition issue if they weren't being careful about how they replaced it. But fundamentally, for example, for a cow, then you need to feed the cow 10 times as much calories as you get from the meat from the cow. So there is an inefficiency in eating our food via animals. So if we then were to be able to use some of the land currently used for growing food for animals for something else, what would we do with that land? So in terms of, some people say, how can we help reduce greenhouse gas emissions? We already have this amazing thing called a tree, which can help suck carbon dioxide out of the atmosphere. So if we can have more things like trees and plants generally sucking more carbon dioxide out of the atmosphere, that would help significantly. Yeah.
Well, my question is very similar to what he's just asked.
Yep.
I've got friends who are vegans and then trying to push me into becoming a vegan, even though I'm more of a moderation is the key. So how sustainable is it if, let's say, 75% of the world population become completely vegan? What is the complications or pros and cons of if we all become plant-based eaters for the world and the climate and all that?
Great. Okay, so the vegan question, yes, it's a good question. So in terms of, it's possible to, when I first heard about all of this, I went vegan, I was so shocked, and I probably stood by the oven with my jacket potato in there, feeling very smug, unpacking my suitcase from a transatlantic flight, and probably heating up some Kenyan green beans, which are all, all vegan. My baked beans was waiting for me. So it is possible to be vegan and, not do exactly the best things for greenhouse gas emissions, air-freighted fruit and vegetables, for example, cooking methods, cooking with the oven on a lot with fossil fuels. It's possible to be vegan without necessarily reducing greenhouse gas emissions if you have a lot of air-freighted fruit, for example. But overall, if we were to cut out animal products from our diet, if we have the right B12, vitamins, and the vitamin D, which is anyway supposed to be something we supplement, then there's not a major problem with that.
Hi. Hi. You didn't say anything about goats.
Goats. Good question. Yeah. So when I first saw this about the milk, I'm like, where else can we get milk from? So I started to do a bit of research on this. Turns out, unfortunately, goats also are ruminants. I'm sorry to bring this to you. So there's a lot of other animals that produce milk, however. Pigs do produce milk, but you have to alternate which teat it comes from every 30 seconds, and pigs don't like being milked. So don't do that. I've looked into other options. Donkeys and horses also produce milk, and they're not ruminants. So I don't really foresee horse cheese taking off, but it would be lower greenhouse gas emissions. Thank you.
Unfortunately, only got time for one more question.
Thank you. I'm quite interested in a future that involves a diet incorporating insects.
Okay.
And one of the concerns I have about lots of people becoming vegan, and I'd be interested to know if you're aware of any research into this, is that I understand that a lot of soya is grown in the Amazonial area or in the equatorial rainforests, and that growing soya and producing soya is now the main cause of equatorial deforestation. And I think sometimes people are quite quick to ignore that or not think about it or not look at where the soya is coming from. I was just interested if you'd looked into that and had any research.
Yeah, absolutely. So that's a great question. So a lot of people are concerned about eating soya when it is true that a lot of deforestation is currently happening to produce soy. Most of the soy that is produced is fed to animals. Soy is an extremely efficient way of producing protein from the ground. If you want to eat insects, the insects have to eat something. And one of the kind of protein sources you could feed to the insects could be soya, but they have to eat something. So in terms of greenhouse gas emissions, soya is not a problem in itself. It's the fact that we're growing a lot of soya to feed to animals, which is a very inefficient way of us getting that protein from the soya.
Okay, sadly, that's all we've got time for, so please give Sarah another huge round of applause.
Thank you. Thank you.